Okay, so I forgot to record the webinar I just did, so I'm gonna do it again. So I'm gonna start off by opening up the new version of Lopack. This is version 3.4.0. This is just the beta version that's out right now. The full version should be out soon, so it might be a little buggy. So the first thing here is you see a couple different apps here that you can choose from. The one that everybody's familiar with in previous versions, in the 3.3 and lower versions, is the Mighty Station Calculator. I just went ahead and clicked that. Take a second to load up here. The other ones is Survey File Creator, XS or Cross Section File Creator, and a new LoCAD. So it'll first come up with this prompt. You can hit Do Not Display Message again if you don't want to see it again. And it will also not pop up this help menu again. So this is the help menu that you'll see all throughout the My Station Calculator. It's not complete in this beta. What's new? This is not even filled out completely. There's a lot more that's been added. So here you can see all the different help options that are relate to the tabs here. And what I mean by that is in the main My Station Calculator here, there's all these tabs down here. And those correspond to those tabs in the help menu as well. So first thing we want to do is load up a baseline here on this front tab, and I recommend just doing this. You don't need a baseline for everything in the My Station Calculator, and actually for quite a lot of it you don't, but it's better just in the beginning of a project, just load in your baseline, and then you'll be set. It'll stay saved in here, and then you don't have to reload it again, and you don't have to worry about any other problems that you might have. So let's go to this gear icon that says baseline, and it'll pop up with this prompt, and you can download any or upload a baseline in any of these four ways. One of them is a planned line file, LNW. One's a dredge survey file. One's a DXF. And if it's a DXF, you just want to have it be just a polyline in the DXF. That's it, just one polyline, and that'll be your baseline. And then you can use this wizard down here below and just start making a baseline from scratch. So I have a LNW, so I'm going to go ahead and click that option and go and find my LNW. I'm going to load in Anthony Beach baseline. So I'm going to enter in the start station. I know my baseline in this LNW starts at station 1200, but for us, we're not going to enter in the plus sign. Then if you, there's a couple other options that have been requested over the years. This first one came from the Long Island project, where their cross-sectional lines were not perpendicular to the baseline. They weren't right at 90 degrees, so you could do an angle to the baseline or a bearing. And you can find that in your plans and specs. Also, for this Jacksonville project I'm currently on, never seen this before, but at every point of inflection, the stations start back at 0, so that's another option you can choose there. We're just going to leave it without those options, though. So the baseline has loaded. On the right-hand side here, you can see a visual of the baseline, and you can see it goes from light blue to dark blue, alternating, and those are just differentiating the different legs, as what we call it in Lopack here. So you can see on the left-hand side here, this column, that's just the legs, and basically that's just every leg separated by a point of inflection. So this PI1 is just the point of inflection. There's just the station at the first point of inflection, and then to the second one. You can see down here it goes from -12 plus 0, to 0, 9 plus 19. That's that first leg here, and X and Y for that, the distance between the two PIs, the azimuth, and the bearing. And I'll do that for all of the PIs. One thing you could do is, if for some reason this mostly occurs like if you're loading in a DXF to make your baseline, it might start at the wrong end. You put in station -12, but it really -12 started at the other end. So you can hit swap here. And you can see on the right hand side it just switched it from starting at -12 the other way, and it'll recalculate everything else in this table. I'm going to swap it back. And yeah, so this in this table is just for information. It's used in calculations elsewhere in the program, but it could be helpful too. So on the right-hand side here, top right corner, you can see the save icons with SUR for survey file, LNW for plan line file, and DXF. The survey file will just export a survey file for each of these legs. So in this case, we'll export out 7 survey files. Since survey files can't have PIs in it, that's why it creates 7 different ones. And then you can load that into your dredge background. The LNW, you can save this polyline as an LNW. I'm not going to do that because we started off with the LNW, but let's say you started off with the wizard or survey or any of the other options, you can convert that to line file. And the last one is a DXF. So here's the DXF options here. So at each station here, you can either have it a tick or a line. You can make almost like a line file based off of this. If you do select line, it's just the spacing of the lines and the length of the lines. But we're going to do tick here because I'm going to show you how to put this into your master drawing. A real quick and easy way to make a baseline for your drawing. That otherwise would take a long time. So you can just select your major ticks, minor ticks. If you want to label on them, the spacing between the ticks, the tick length, the text height. If you want ticks at the PIs, your label offset from the tick, and the flip label is you'll have to just see if you make it, and then you see that the labels would look better if they're flipped upside down, or you can do the flip label. So I'm going to click done. I'm going to export this as Bethany Beach baseline, Beth baseline, and I'll open it up so we can take a gander at it. Exports. And here we go. It just made all this. You see it overlapped because there's a PI right where it happened to be at the 100. But yeah, you can see here every PI has this, the major ticks and the minor ticks. And this could have taken forever. Here's my current project. I mean, this is a huge baseline. I mean, copying all these points, getting the right angles to them, and to get perpendicular, and changing all this text would take a long time. So I mean, it does it in a matter of seconds. Okay, so that's everything on the baseline tab. And the first place that the baseline tab comes into effect, it only affects the rod and level and my station calculator tab. So this my station calculator tab is probably one of the more useful tabs in this spreadsheet, or in this program, and I'm going to explain how to use it more than the other ones in here. So I'm going to go to import data here, and it's going to bring up this dialog here. Then this is everything that you can import into the program. There's a lot of different options. And then here, I'm going to go to this help menu up here. So this is everything that you can import, and then this is everything you can output or export. So if you have any questions, you can just click on, let's say you want to load in an LNW and export it as a DXF. You just hit this convert button, and it'll show you how to import LNW. It'll go through the steps on how to import, how to export. If you want to clip any of the data, shift it, you can clip and then double click to get out of that and clip data. Oh, I'll just scroll down there. Yeah, and you can see. So any combination. The way I like to use the MyStation calculator is I know I have an XYZ, and that's what I'm starting with, and I'm trying to make, or let's say a target file. I'm starting with a target file, and I know I want to make a DXF of circles everywhere with labels on there. I might not know that if Lopack could do it or not, but hey, I know I have a target file in DXF, and hey, sure enough, you could do it. if you don't know, you might as well just try, or even just ask me. My contact information is on this back page here. So I'm going to import to start off here. Actually, we're going to start off making a dozer template or a 3D polyline of a beach. So I'm going to pull up some plans here. We could take a look at what I'm referring to. So here's the plans for Bethany Beach, and you can see here that here's the baseline right here with the stations, and then it has your elevation, and then the station and range. This 205 is just the range, the distance from the baseline, which is a range. So as you stop the slope, berm, seaward edge of berm, it gives you everything you need. But now how do you create this into a dozer template or a beach template, a 3D polylines to add into your a template embedded line file for your cross sections? I mean, so this is how you can do it real quick. So you can open up a Excel document. I already have it made, and so here's all the stations, and you can just copy this down real easy. You just copy and paste this down, and then you'll be done with the stations. That's easy. The next column is the range. So the station, range, elevation, and then ID. So the range, this is going to be a little bit more tedious, but it's not that bad. You just go in here and get all the ranges, which is all here. You just got to type that in. No way around that. And then the elevation, I mean, it tells you right here, 7, is the berm. You can come down there and just drag that down. Drag it down for 30, and make it real quick through here. Then the end is just, you want to label. So each station just has one. So from -2 + 0, 0 to 50 + 0, 0, that's the berm. And we start again with the top of slope, and then with the center line of dune. Let's see, seaward edge of dune, crest. Or, you just keep going down for each of those lines in the plans here. So then you can save that as a CSV. And then you're going to come to import, and you're not going to want to import a CSV. This is, you can use this for many different things. The CSV, any type of CSV will be imported, but it's primarily designed for importing in a X and Y coordinates, X, Y, and Z. So like from your survey controller, it spits out a CSV, so you do that. Or ADISS, ADISS spits out CSV reports, so you can use that as well. As long as it's in the first 5 columns, the data, the X, Y, and Z data, then it doesn't matter what order. You might just have to adjust your CSV for that. But in this case, we're going to do station range because it's a station range elevation CSV. And I'm going to want to, just hit yes. And then I'm going to locate that CSV that we just had open. And it's going to ask us if we have IDs in the 4th column. And we did. And I'll explain why that's important in a second. Why you would want to hit no in certain cases. So now we can see everything's loaded up. We had the station range elevation from our file, our CSV, the IDs, and the XY. It converted it based on this baseline. And it tells you here what leg it was in. So this first berm point, station 2 was in leg here. So yeah, it's between -12 and 9. So yeah, 2, that makes sense. Or yeah, leg 1. So now we have that imported, and now we want to make a 3D polyline real quick out of this. So we just go here, find our DXF, because that's what it is, DXF polyline, hit done, and then go to 3D polyline, and here's all the different options, but we'll just click 3D polyline, and so what continuous will do is we'll make one single polyline for all these points that are loaded in the MyStation calculator. It'll just make one single line. But if you hit uncheck it, everything with similar IDs names, or the same ID names, I should say, it has to be exactly the same, will create one polyline, and then it'll start the next one. So everything on a berm will be one polyline. Everything with TOS, top of slope, will be one. Everything with the center line of the dune will be another one. So that's what we want. And then you can come here, and it doesn't matter what color. You can select a custom color if you want. let's just say 12, this purple color, 214. Then done. It'll ask you where to save it. So we'll save this as best each template. Okay, now we can open that up. And just do Z enter, E enter to zoom extends. We have this purple, that's kind of not easy to look at, but then we can see these are 3D polylines here in the properties, and we can cycle through the vertices and see that the Z value here, all the Z values that we had inputted in are in there. There's the berm. So there you go. And then you can enter that right into your dozer template, or use it for intersector and Hypack to cut templates for your cross sections. It's very useful. All right. The next thing you do, let's say you already had the 2D polyline of your beach and you want to convert it to 3D polyline. Well, sadly, AutoCAD can't do that. It can't go from 2D to 3D polyline. I don't know why. I think Civil 3D can, but AutoCAD can't. So how do you do that? Import data. Well, let me open up just to show you guys first. So 2D polyline, DXF. And here's a 2D polyline. All these you can see just a regular polyline. But they all do have elevations in it here. 6, 6, and the top is in here 12. So I'm going to go here and import a DXF. And whenever you import a DXF, it can only be a polyline or a circle. That's the only two things that it will accept. And I'm also going to hit the select or shift data. I'm just going to show you this feature here. You can, for any of these imports, you can hit shift or clip data. And this clip is just clip to a border file, and shift gives you a whole bunch of different options, which are right here. You can shift the X or Y in any direction by any amount. You can shift the Z. Let's say I just want to shift this template up one for whatever reason. Difference to level is just, let's say you had a sounding or a Z value of 10 and you put a 20 in here, that difference will be 10. It just takes a difference. So the new Z values that I'll put in the MyStation calculator in this column will be just the difference. You can remove points above and below a certain Z value, which is very, very useful. You can replace points, certain Z values, and you can invert the Z. So we'll just shift it by 1, just for the sake of this. Okay, that's going to ask where to save the DXF. So beach template 2, because we already created this one just the other way. Oh, it's asking me to open. Oops, sorry. So our 2D polyline. I'm skipping ahead here. So that was just asking. It was outside the limits of the baseline. It must. So this -12 right here. It must just be like less than a tenth or whatever, 100th off. So, but it will calculate it outside the baseline limits. But it was just prompting you, asking if you want to or not. So yeah, we did. So now you can see it has polyline 1, which is that first polyline. The second one, for the berm, the bottom of the slope, whatever this is, the dune is next down here. So then we can export this as a 3D polyline. So DXF, and then 3D polyline. And again, we don't want to do continuous because we want it to be separated by the ID name. And then exports, and now we can save it. Beach temp. Okay, and I'll just open that up just to show you. Z enter, E enter, and here you go. And here's a 3D polyline with all the Z values for all the vertices. So, I was going through and explaining that, but it only takes a second. Just import the 2D polyline, export the 3D polyline. You're good. And in this case, we've also shifted the data as well. Next, I'm going to show you how to another thing that you can do. I'm just going to go through a couple of features that I think are pretty useful and pretty important. I mean, the options are endless. I just want to kind of throw out there what it's capable of doing, and if you just think you have one file type, you're trying to get to another, and no matter what you do in the middle, it could figure it out. It'll prompt you for certain things. But I'm going to show you some important stuff here. So let's say we have an LNW and we want to go to a CSV for A and B points on your survey controller. So you can plug them in, and you plug in the A point, the B point of your station, and you go survey on that line. So let's see. So we have an LNW. That's what we're starting off with. We know we have our line file that has the cross-section lines on it. So we're going to find that. So Bethany Beach cross-section lines. And now it's asking, do you want to put a suffix on it, the A and B points? Well, yeah, but that's what we're trying to do. So hit yes. So we would hit no. Let's say we want to create a DXF of this. We would hit no, so then it wouldn't have the A and B suffix at the end. It would just be that line, and now these IDs would be the same for the start and end. And now you can make a 3D polyline, a 2D polyline, whatever, and make it not continuous, and it will separate the lines into multiple different lines. Otherwise, if they're unique IDs, then it will just create one single polyline. So for this case, sometimes we want to hit no if we're making DXF, let's say, but for this, we want to make A and B points, we hit yeah. So you see, because all these A and B points here, and it lines up with the station range, or, well, you don't know the range, but it lines up with the station here. So then we can go ahead and hit export, and we want to export it as a CSV. CSV. I hit done. And so this is really customizable. You can export anything in the Mighty Station calculator to, anything with 8 columns, and you have the options are everything that you see in the columns in the Mighty Station calculator. So leg, ID, XYZ, station range. You can also add in numerical. So let's say for some reason you want to count all the points, 1, 2, 3, 4, 5, keep going down for each point. Custom, if you click that, it'll later prompt you what you want in each column. Like if you make it all custom, then it will just all prompt you for column 2, what do you want it to say? And you can type in whatever string value, whatever text you want, and it will just add that in there. So in this case, for a survey controller, we want to put an ID for the first column, an X, Y, Z, X, Y, Jesus, and then Z. The Z, you need the Z even though it's just 0. For a survey controller, the DTM file won't work unless you put something in that fourth column. So we're just putting in that 0. And the DTM file will actually put the elevation in there. So we'll save this as controller lines, AB points. Okay, and we can open that up if we want to take a look at it. And here we go. It's made that CSV with the X, Y, and Z and the station name. Load that into your controller, you're ready to survey. All right, the next thing I'm going to do is I'm going to go load up a new baseline because I want to show something different, a different project. So I'm going to load in the Jacksonville projects baseline, and we'll say it starts at station 0. I forget if this baseline actually does or not, but for our sake, let's say it does. The next thing we're going to do is hit import, and we're going to make a number of buckets map. So on the background of a dredge, you can have face showing, the face to your target depth or face to the channel, but you can also put number of buckets so the operator knows how many buckets to take in each area to get down to grade. So let's say we just surveyed, so we have an XYZ. And I want to actually clip this XYZ because maybe I just want to clip it to the acceptance section, let's say. So we'll clip it. So we'll choose our survey. It's 12 by 12. And for a for a bucket map or number of bucket map, we can do we can enter in a survey or a channel difference survey. It doesn't matter. If it's all one depth, you could just do the survey. If not, you'll have to make it into a channel difference before you do this, because if there's slopes or anything like that, we'll just say it's all the same depth right now. So here's the clipping data option. And the real cool thing about this, unlike Hypack, you can clip multiple border files at once. So we can go browse, and let's say we want to select 2. And you can do as many as you want. It could be in any combination of in and out, doesn't matter. So now we have those loaded up, and now we can clip data. So yeah, I mean, if you wanted to, once this is done, you could just export this as XYZ, and you can clip it. Now you clipped one XYZ to all these border files all at once, instead of clipping it, saving it, clipping it, saving it, and then like you would have to in Hypack. So I clipped it all the border files at once. So this is the result, and we want to export to number of buckets, like we were talking about. So here's the dialog for that. So like I said, you can do a channel difference, or if you just have the plain survey, that's where we have the plain survey. We put in the bucket byte. It's usually around like 2.7, something like that. If you don't know how to calculate that, it's you know, let's just say a 12 cubic yard bucket. 10. The width of the bucket is 10 feet by 20 feet. It should usually be between 2 and 3, or I guess 1.6. I guess that was a big bucket. Let's just do 18 cubic yards, 10 by 20. I'm just putting in weird numbers. I don't know the actual size of an imaginary bucket here. So grade, we're digging to 48 here, and 49 is what we're targeting, which is the over depth. Now you have the round up or standard. Normally you would want round up, because let's say if it takes less than a half a bucket to get down to grade, well, hey, you still have to clear it to grade, so you're going to put it as 1, because otherwise, if you just do standard rounding, it'll round down to 0, and you won't take a bucket in that area, and you'll leave material above grade. But sometimes you want to do standard. Some projects, that's why it's in here. Some projects wanted to do standard because sometimes if it's mud or more so if they know they're going to drag, they want to be productive and only take full buckets. So anything less than a half a bucket, they don't want to take. But it's just something, a lot of times you just have to play around with it, but round up is where I would start to be safe. Then you can export this as a DXF for your dredge background, or an XYZ, just to have that on file as well. And the angle, you can just leave that at 0 or blank if you want it to be a 0, or type in the text angle. The text height, let's just say 6. And you can have all the text be black or colors. So the colors here, so if it's one bucket, it'll be color 10. We go down to this table down here, color 10 is right here, this red color. In order to change these, let's say we wanted if it shows one bucket, we want it to show green instead. You can go up here, click green. Second bucket, we want it to be blue. We can choose this blue over here. If you wanted the next 3 buckets to be yellow, you could click that. You can make all the buckets one color if you wanted. Down here is the same thing. You can choose certain buckets, make it that color. Then it all changes it down here. It's all linked. You can also save this color file, and now it's saved as a Lopack color file. It won't work in Hypack, but you can load, and then you can load in a color file. So here we go. This is just the default that was already there. I saved that earlier. So we're going to click done, and now it's going to be making our bucket number of buckets map for us. So export, save. And we could take a look at that once that's done. Looks like it's done. Oh, it's asking us to save the XYZ as well, because we had that kept off. So we'll open up the XF, and wow, beautiful. You can load this right into your background, so the operators know, like if they see this 5, or they're digging over here, that's 5 buckets. They got to take 4 buckets down to grade there, so on and so forth. 1 bucket here. And it's utilizing those colors that we previously looked at. Okay, next I am going to do Dredge Database. So I'm going to import, go to Dredge Database here, and it has the ability to import DRG, PRO, or MDV. You can go to all files here and do a custom format, but it's not a. Yeah, I guess it should work. As long as it's labeled with column headers and has data in there, it should work with whatever type of data you have, but dredge data you might have. But let's just go to PRO to show that for our hoppers. Just got to be patient because it has a lot of data. So we're going to pick right here in this upper left-hand corner, what are we actually going to be loading into the Mighty Station calculator? So for the ID column, let's upload the time. But you can put in whatever parameter you want. This is pulls from the PRO, all the headers from the PRO. So you can the time, and then we want X, Y, so X, Y, and then like the Z value. You could right now it's just defaulting to the depth, the port drag head depth. You can have the Z value be anything, and you could even put it as something weird like I don't know, like the speed or I don't know, the velocity or something like that. And so this way here, you can treat that Z value as something different, and then you can export it to a DXF with a label, a point with a label, and then I'll show you the velocity at each point. So you can just be creative in that sort of way. Then here's some filters on the right-hand side. So if you only want to do certain times a day, and then the dig, if you only want to export or import, I should say, dig tracks. If they're not digging, you don't want to see it. So you'll see more stuff comes into the filters. So you can put in a minimal depth. If they're above 30, they're not digging. If they're below a velocity of 8, below a density of 1.03, then you know that they're not digging. They're not pumping any material. So you can also change this to whatever values you want. That's just the default. And then over here, you just want to this is just to verify. It uses these columns, so you just want to make sure it's pulling the right stuff. So this port depth, starboard depth, starboard. And if it's not right, you can go in here and change it. It uses an algorithm to figure it out. No matter what the PRO or MDB or no matter what type of dredge is coming from, it uses it. But it could potentially not guess it if you have weird column headers or abbreviated column headers. It could possibly not guess it correctly. So you just go in here and change it so it matches it up. And then if you wanted to export the dig tracks, you could do here. And the same thing, you just want to make sure these match up down here. And it will export a DXF with a 3D polyline. All these will have, if it's like MDB file for cutter, this will be 3D polyline because it also has the elevation of each point in there too, which could be pretty useful. And in this case, it will have the green, do a green line for the starboard side, a red line for the port side. Then you can save the clip database file, so it'll save a new database file based on these filters. I'm going to cancel out of this, but I'm going to show you a DRG though, just because it has a little bit less data in it. It'll run a little bit quicker. The Dredge Database, DRG. And you see it also has the options to export this as bucket tracks, because Hypack deals with bucket tracks. So we'll just leave this as is. We're not going to do dig tracks only. We'll export all the data. Let's let this run real quick. So this could be really useful if you're trying to. Somebody in the webinar asked a question about make sure you're digging if it can filter just that, and we were just looking at that, and the answer is yes. It was really good to see if you dug outside the bar area. Maybe you sailed outside the bar area and it was really close, but you can analyze it and see, hey, I didn't actually there wasn't any material coming through there. through the pipe. There's no density, no velocity, so we weren't actually digging. So that can save you there. I've used that this many times for that. If you get this error, just hit OK. I don't know why it does it. I haven't been able to figure it out. So you can hit export, and we are gonna clip the data again just to make it a little bit smaller. And I want to, instead of doing a DXF this time, I want to export it as a polyline and circle, but not have to make another file that I have to copy and paste from. I just want to just put it right inside my open drawing. So let's do a polyline, and I'm going to clip the data to this border that I pre-made. Clipping that data. Take a second here, and then it's ready to copy to. It's already copied to a clipboard, so I can just go into my drawing, paste it in the command line, and boom, it's drawing this line right here. So this is the dig tracks. Well, not just where the bucket was swinging, not necessarily if it was digging, because we didn't apply that filter. Same thing, we can delete that, and if we show you the circles, you can do the same thing with the circles here. Let's say the radius of the circle is 2, whatever. Go into our drawing, the command line, Control V to paste, making these circles here. It would be really helpful to be quick, to see something real quick without having to make another file. Okay, moving on. I've used this for ADISS data as well. I'd hit import CSV, and then export DXF, and made something like this. I make this often for our server packages to see where they're dumping. This is the load. So I had the load numbers coming in as the ID, and then the XY points. And then you can export with a circle, crosshairs, labels, change the colors of it. This is all in the DXF output options. This is real handy. I mean, instead of plotting each one of these one by one, and you get a cooler effect. You can choose different colors for the crosshairs and circle. Whatever, play around with. Yeah, so I think that's it for the Mighty Station Calculator tab. Rod and level, this is probably a lost start here, but if you ever have to rod and level, instead of, you make all these field notes and you go back later and create an XYZ from all your field notes by hand, and it can be real tedious. You're measuring from the baseline and writing down, making new XYZs in AutoCAD or Hypack, and it's not as accurate, and it's real tedious. So here it's like there's a wizard. You hit the start menu. It just walks you through it step by step, and you just enter in your field notes, and it will create XYZ. And here you can just see like the diagram and the instructions on what it's asking for. Based on your field notes here, your backsite, foresight, that whole thing. So moving on to object files. This is a big one. I've had tons and tons of questions about this, and there's been bugs in the old version, and been sorting through a lot of them. It runs pretty good for me, at least, so we'll see. So now I'm going to import a line file, and now you can import line files with a template in it. You can see it says A here. That's Hypack's default. If it has an A in it, that means it has a template. The previous version it have no templates in it, but now I'll import it. It'll just ignore it though. So now we're going to import a DXF. Actually, before I do that, I'm going to show you what the DXF looks like, how to make a proper DXF for Lopack object files. So first and foremost, everything has to be a polyline or a text. No MText, no lines, no blocks, nothing. Make sure you can hit Control A and it'll select everything in the drawing. Come up here in the top left corner, text and polyline. That's it. So there's a couple different methods in Lopack. There's minimal text, there's border method, and then there's if you have just both of them unchecked. So the most effective one is border method. It's the most accurate. It's least likely to give you a wonky result, and if you can use border method and adjust your file to use it, then use it. So what that means is a border method is you have a closed polyline. You can select your polylines here, then go over to the properties. And you can see that it says closed right here. All of them say closed. It says yes. If it didn't, then it might give you some problems. The next thing you want to do is make sure you have text, not mtext, and that these blue dots are located inside the respective polyline. And then that's it. Another errors I've seen, people have hidden, frozen, or turned off layers, and there's data on there. You want to make sure that everything is unfrozen and deleted out if it's not there, if you don't need it. The only thing it should have in the drawing is this. Make sure there's no polylines or lines hiding underneath. If you delete it out, or is there anything underneath it? That's why that Control A and making sure that you have 6 with 6 polylines to 6 text. That's all that's in this drawing. So I got a lot of errors just because a lot of people come on to me with errors saying that it's not working, but it's just because their polyline, their DXFs weren't set up correctly. And countless of them. So here's a visual on the right hand side. It's another little double check. The lines are shown as lines, and those dots are where the text locations are. And we have border method checked. So this first tab on the left here is line, the line width of your object file. If you want it solid, the color. And then you can choose that. Your text, you can choose the font, size, bold, the font type, everything. And here's a new feature in this new version, is a DBL offset. So the way Hypack works is it's left justified, the text, but in Lopack it's centered, and that's the only really way you can calculate it, because you don't know based on the text how long the text is going to be, based on the font type and the font size. It's really difficult, so you kind of sometimes have to play around with it. You might have to export object files a couple times, check it in Hypack, and come back and maybe adjust this number. A negative 15, negative 10 usually works out really well, because it just offsets that difference from the centered text in Lopack to the left justified in Hypack. Just compensates for that. And then the depth, this is just where those texts that we have in the DXF, at what depth do we want to show that? Say 28. Now the depth tab here is what lines you want to see, what vertical, and I guess and horizontal lines you want to see. So the start, these first two here are vertical lines. So the 0, we're saying the vertical line is going to start at 0 and it's going to end at 49, which is, let's say, our over depth. And then if we want to put a strike line at that, a horizontal line, we can at 0, we can hit it for the start strike, and for the end, we can do end strike. And it'll create a horizontal line. Maybe we'll just put one at the bottom. We don't need one at the top there at 0. Then if you just want to have another strike depth, we could do 48. So in this case, 48 is our grade, 49 is our grade. And this smart depth option is if you have a drawing, it has to be a 2D polyline drawing. So if we were to open up that background again, so let's say we can put elevations to these 2D. So let's just say we want this one to be 48 feet and this one to be, I don't know, 47. And you go through all of them. I'm not going to do it right now, but you can, maybe I will go through it. That'll be cool to show. So 46, and then maybe this one goes back to 48. I'll just select the other two, make it 49 or 50 or something. Okay. And then, this actually brings up a good point. All DXFs in Lopack need to be saved as this R12 LT2 has to. So we'll just do smart depth. Hopefully I put elevations in for all of them. I can't, kind of going quick. Okay. We'll do that one right after. So we'll do preview objects for this one. So I'll show you the difference. So right now it should have a line at 49 and 48. And the only reason because there's one at 49 is because we clicked end strike over here. If you have anything in the strike depth over here, it'll put it in there. So here we go. Here's a preview. This on the right hand side here is just the line file and the DXF together, so you can see it. Make sure everything looks good. And everything's like a little squished right here just because it's going from 0 to 1400. So we can just click on that and go to 900 to 1300. So open that up a little bit. And you can see how it's like favoring the left hand side right here. That's that text DBL offset because this is centered. So now in Hypack, right where my cursor is here, it will move it where like the 2 is. It will move it the A to where the 2 is, and then it'll be centered right in the cut. So it's just the difference between Lopack and Hypack there. You can change it from depth mode to elevation mode. So yeah, let me load in another DXF here, that new one that we made, the Smart Depth. And this time I want to do the station name. If you don't like the station name, like .tin or whatever that you see in Hypack, you can just create a nice normal looking one with an object file. So this is what depth you want to create the station name at. Let's just say, I don't know, 25. And then do you want to add the station prefix to it? So it says just the line name, or do you want it to say station and then the line name? So let's say yes, we want the station too. The other option here is dummy object. That only applies to when you create objects and not preview. That will just create objects, blank objects, if there's no, it doesn't intersect your DXF at all. So your line file doesn't intersect it. Maybe you have 100 lines in your line file, but only a couple of them intersect. It'll put in blank object files just so it's easier to load into Hypack. And you don't have to mess around with like arrowing them up and down and organizing them. And go over here to depth and make sure it's checked off. And then the over depth is just going to be one. Just one foot past the smart depth. Hit preview objects. And we'll also see the station name in this time around. Probably works a little bit slower since it's trying to get all the elevations of those polylines now. Okay, perfect. Change the zoom here. And you can see that it's made this stair step because we're changing the elevation of this. So it automatically pulled it in. You can see the station name in here now as well. So what you could do is you can scroll through these what do you call it, lines here. If you wanted to switch the text around, you can select a different text, then use this button over here to move the text, and it should save it in the right spot. If you wanted to add a text, you can hit here and then type in your text. So let's just say, I don't know, centerline DBL 1175 or something. Oops. 1175. And then the depth, maybe we want at 20. Then you can hit add to all lines and it'll add it in there. I'm not going to do it because it's going to have to recalculate. So the other option here is you got this DBL offset. What that does is it just changes these DBLs up top here. So if you put this negative 500 in it, it'll subtract negative 500 from this. If you add it, if you just do that, it'll add it. So in this case, if you hit this button here, it'll recalculate everything, and this start line right here would be 1500 and so on. Somebody asked me for that a while back to adjust the offsets there. So the next things I could show you is the difference between minimal text and not minimal text. So we just did the border method. So now the other option is minimal text here. So let's let's open up a drawing to kind of demonstrate that a little bit better. So we had on Long Beach a sand fence. So here we go. We got one polyline here. Control all. We see two things: polyline and text. That's fine. But so there's going to be line files working perpendicular to this sand fence. So how do we get this text to show next to this line for all the object files? So you can see that this has different vertices in this polyline, a bunch of them. So on minimal text, it will just find the closest vertice, so it'll be between these 2 points, these 2 blue dots here, and it will assign this text to that, just between those 2 points. So that might be good for only a station or two or something, whatever, I don't know what the spacing is. But if you unchecked minimal text, it will apply the sand fence for the whole entire thing. So sometimes maybe you only wanted to show it between these 2 points, you only have that word, or like maybe there was something over here like lifeguard station. You can move this over here. Oops, I had that. And then there's a lifeguard station, in this vicinity over here. You know what I mean? Or you could change that to text to lifeguard. But I'm not going to do that. I'm just going to exit this out. So I'm going to demonstrate both of it. So the line file is Long Beach line file. The DXF is that sand fence. And we can just leave all this stuff the same. There's no smart depth in it, so I'm going to check that. Say 15 feet or whatever. And then we're going to I'll show you minimal. So this one only at one. You can see just at probably one of these stations here on this right-hand side. You can see that red dot is where that text is. So we'll scroll through and pop up anywhere. There we go, sand fence. Oh, I guess I had the text at depth 28, so it's down there. And that's only going to 15 here. But 28. But you can see it only showed up from one of those lines because it's only between that segment. But if I uncheck that, hit preview objects, then you'll see it's here for all the lines. It looks kind of far away, but it's just because we're so zoomed in. We're only spanning across a DBL of 30 feet or so. If I just change that to 0, you can see it sticks it to it a little bit better. Okay. And you could have adjusted this so it's not overlaying this line if you did a DBL offset. The last thing in here I'd like to show, let's clear this out. I'm not going to go through it, but if you had an LNW here, load in your LNW, then you can hit cutterhead here, and it'll ask you for your MDB. I guess I might as well go over it. These MDB files could take a second to upload. But basically what it's going to look like is if we have cross sections here and we want to show where it was swinging to, it could different lifts. You can see here that it automatically makes these circles. You can see here that maybe it's calculated a little wrong because this project we're rock chopping, so it didn't filter out where we're digging as nicely as it should. And what I mean by that is here you can see like the dig filter. So we only want to show where we're actually digging. But since we don't have any density or velocity because we're only chopping, we could hit disregard here. And it'll give you a little bit funkier results, but you could just go in the object files and delete them after. So just make sure that this is lining up with your MDB file. It has all the columns in your MDB file here, just like we were looking at before. Just make sure those line up. Make sure that these line up, the X, Y, and Z of the cutter, the time, you can filter it. Make sure the spuds line up because it uses the spuds to determine what cut it's in. So if you're dredging an adjacent cut, it'll still show where you swung to. And then this lift filter is just if it's within 3 foot of the main depth that they're swinging at, then it won't create a different lift. there's a filter in it because it's not always going to keep it exactly at 50 feet. So if they're doing a lift at 50 and a lift at 45, 3, if it's over 3, then it'll be considered the next lift. The Z offset to the cutter is if your MDB file is already calibrated to the tip of cutter, you can just leave a 0. Otherwise, you've got to put in that whatever it's calibrated to, so the bottom of suction to the tip of cutter, whatever that offset is. And the cutter diameter, just whatever cutter you have, you put that in there. Click done, and it will spit out object files. Well, you click done, and then you just hit create objects, and it'll create it. Just make sure everything else is cleared out like it is now, just the line file and that. And then this pipeline option is not coded yet. But yeah, like I said, it will show you exactly where they swung to. So if you have any questions about surveys, why didn't they make grade? You can see, hey, well, they only swung to this. They left all this on the slope because they only swung to right here. Okay, so border files. This will go pretty quick. If you have a DXF of a border file or multiple border files, well, if you have a DXF of just a closed polyline, and I'll show you an example of one here. So this is for the Jacksonville projects. It is, where is it? Just all of our acceptance sections. There we go. And you can see here all of our acceptance sections in the channel with text in the middle of it. So if you wanted, you can leave the text out and it will just name the border files numerically. But if you wanted to actually assign this closed border, so we can check again here, it's a polyline, you can see the properties and it's closed, and with the text in the middle of it, just like we were doing with the object files. So we can see that it's all, if you select all, there should be 14 here. But you can leave out all the text and it just won't name them that. I'll show you in a second what that means. Make sure to save this as DXF, the R12 DXF. There's that error again. So we can base acceptance section. So here's all those acceptance sections we were just looking at, and see how they're all named based on that text. And actually that in and out point will be based on where that text is. But you always want to put it in because it won't know if it's out. So if you want it to be out, you can click this in button here and it'll change it to out. Likewise, you can change this these arrows down here and see when it crosses, it goes from in to out border. And then you can just go through and just make them all out if you wanted to, or all in. It doesn't matter. And then down here you can see the area. Just in case you wanted to see what the areas are, could be a helpful tool. Then hit create borders. I think I already did this. I already did this in the last, when I was actually doing the webinar, so I'll just show you what it popped up with. So you can see here, I made all these borders and they're all named what the text was in the DXF. This MultiClipper, I'm just going to get rid of the ones I made before. MultiClipper is, you can import a XYZ and then also multiple border files. Select as many as you want, in or out, and it will create XYZs based on those border files. So unlike in the MyDistinction calculator, where if you did the clip down here, it will clip all the border files but only have one output. Here, it will, with all the border files, it will make multiple outputs, so one for each border file. So if we do MultiClipper, oh, did we just already create that? I wasn't paying attention. Yeah, so you can see that it made an in and out because we loaded in those two borders and they're named based on those borders. Well, it has like the XYZ name and then the border name after. So it made two XYZs based on those two borders. And then the circle borders, this can come in real handy if you're trying to create a circle border in Hypack. It can't be done. You can't do circles, so you can click a whole bunch of times to get it relatively close, or you can do this, which is a little bit more accurate. So you can just put the center point of of it, radius, and then you can adjust the resolution here. So the higher you go, the more points it will be and more of a circle look like, but you can even leave it pretty relatively low down here. It'll still make a really good circle. So we can just make one of those here, open it up. And this is really good for dredge backgrounds as well, because dredge backgrounds can't accept circles. And I mean, it looks like a perfect circle that you can see here, all the vertices. So that's not an actual circle, it's a polyline, so it'll work. You know, you can also, when you're converting from EXF to KMZ file, which you can do in Hypack, this will, you can't convert circles, but you can do polylines. So if you wanted to show like buoy locations as circles or subline joints, that's a good way to do it. You can export as border file in or out. You can also load in an XYZ too. So let's say you had a whole bunch of points. Instead of doing center points for all of them, you can load in an XYZ, and then it'll gray this out because it'll just use the center points from the XYZ, and then you can make a whole bunch of them. Okay, that's everything on the borders tab and the colors tab. I made this just because I wasn't happy with the Hypack color option that you can make there. So this is real easy. You can just type in different sounding elevations here, or whatever your color file is for. You can copy and paste down real easy. Let's say if you want to skip one, it makes it a lot easier because, you know, setting the bands and everything in the Hypack one is to be a little tedious and frustrating. So now let's say we made all these here. Let me just add another one. You can choose feet or meters depending on what you're in, and that's just, I'll show you in a second why that's important. So you can just click this. You can either click on the row right here and then click color to choose the color, or you could just click on this color column right here anyways. Make that green maybe, and then make this, I don't know, red. And then you can do this for all of them, or you can, if you want to do a smooth thing, you can pick the one that you want to smooth from and drag it to the next one, and it will smooth those colors for you. So now we have a color file made, and if you wanted to save it as a Hypack color file, you just press this button right up here to save to the HCF, which is a color file. Just do that, and then you can also copy it. So you can make the title of the legend sounding legend. Yeah, that's fine. And then we'll come over here. We can paste it now into our drawing. Scale it. We can print it to a PDF. Some dredges, they like to have the color file of the background, you know, taped to the side of the computer. For the operators, mates, drag tenders, Lieberman, whatever. You can also open Hypack color files with this folder open over here. This is a new tab here, the XS tab, the cross sections and volumes. Well, first and foremost, the cross sections are not up and running yet. This is the top right button, won't do anything. So one of the big advantages of this is this report options button. So you can select what options you want in your volume report instead of choosing the predetermined ones that are exported in a predetermined fashion. So you can choose to customize what you want. So you could take out this one, and let's say we wanted the distance between lines here. We can choose the order of it. Get rid of that one. Oops. And then hit done, and it'll save your options there. Load in a template. Let's see. So a template, this one right now it only does a line file template. So open that. We can open up a survey, just the log file, and you'll see that it's not lined up. The stations here don't need to be lined up as long as the station names are the same and they appear inside the line file. They don't need to be lined up like Hypack does. Then you can go over here to the different tabs if you want to calculate volumes to the min and max template. If you want to choose elevation, depth, depth 1, depth 2, if you're high or low frequency. Your volume options are here. And the only one, these two are for special circumstances, but I'll just go over this low accuracy. So you can change it to low, medium, high. High will be more accurate. It will interpolate to the nearest tenth, rather than low will interpolate to the nearest foot. And basically all that means is low will run a lot quicker, high will run a lot slower, but it'll be more accurate. Sometimes they're exactly the same or pretty dang close, so just depends on how fast you want to go and how accurate you want to be. Compensating slopes, you can enable this if you want. Choose if you want material to only fall down into the slope, or it can be compensating in both directions, up and down the slope. And then what segments you want to apply to. In Hypack, it goes from left to right. So if you do 1, 2, 3, it goes from left to right. But in Lopack, it's from right to left. I think that's just a better way to do it because your slope is always going to be on the right. So you could start at 1 instead of adjusting it for every line. You could just do 1. This template over here, this is what the Myrtle Beach uses to redesign their templates. Basically, if you want to readjust your whole entire beach line file template here to a certain volume for the whole entire, you can type it in and then select this, and it will readjust. Make a new line file. It'll make a new 3D polyline and a volume report based on your new volume here. You can do the same thing with fill density for each station or the end area for each station. And in that, you would just have to input a CSV in this column that has both the station name and the end area, comma delimited there. And I have a YouTube video that explains how to do that in depth. But we're not going to redesign any templates here. So I'm just going to click volume report, and it's going to calculate volumes via beach method. And I'll just save this in here. And this beach, so it exports as a Excel format, so it's a lot easier to add into your volume spreadsheet and easier to view. These headers up here are just the headers right here that you can customize. Has all the stations, and this is exactly what we had in the exact order in our report options. This is what we chose, and that's the only thing that was outputted. I mean, we can put all the options in if we wanted to, but this way having it has the totals down at the bottom here. And as a disclaimer, I mean, this is not fully tested yet and shouldn't be used for any pay volumes or reported volumes. This is just a double check, and mostly just used for this template redesign for the Myrtle project. But if you wanted to double check your work, just as another double check, you can use this here. This 3D polyline button is pretty cool. So if you have a template with a line file with a template embedded, you can just open that up and it'll export out a DXF here with a 3D polyline. So if you just want to go real quick from a 3D polyline or a line file to a 3D polyline for dozer templates or anything, this is another way to do it here. And you can open it up, and then you can see here a 3D polyline with elevations based on your line file. So that's all in the Mighty Station calculator. I'm going to exit out of this. Back in Lopack main screen here. The next is the survey file creator. Just going to go over it real quick. Instead of hogging up the Dredge's screen, you can make your survey files right in here. Just type in northern eastern station range, and you can adjust the templates down here for the cross-section view. Just type down at the bottom the depth and the corresponding range. Hit draw. You can change the over depth if you want. and then you could just exit out of the screen and it'll save. You just, for the start and the end, no need to click azimuth and distance buttons because it just does the math on its own. Hit create and it'll save the survey files. Next one is this XS file converter. This comes in handy a lot if you're trying to offset templates, convert a survey to a template. Let's say you're surveying a bar area, and then that's as the BD, you can only fill 5 feet above the BD, or sorry, dig 5 feet below the BD. You could just enter in the edit file from your survey and then export it as a template, and then there you go, you made your templates. You can adjust the Z offsets. There's a lot of different uses for it. One of the things you could do here is create a log file. So if you have a bunch of templates, a bunch of object files, or anything, you can just put it all in one folder, hit create log, locate that folder, and it'll create a log file for all of it instead of having to type it all out. And this last app here is LoCAD. It's a version kind of like AutoCAD, just simpler. The idea is one day to merge it so you can put XYZs, border files, everything into here, and also edit the background. So it's like a mix between Hypack and AutoCAD. So I mean, you can come in here, select things, delete them out. If you want to draw a polyline, you can draw a new polyline. And you can save this as a DXF. So like I said, eventually you can be able to drag and drop surveys in here and then export this as a bat map and what have you. But at the moment, it's just another way to another CAD. Alrighty, that's it.